Okay, perpendicular lines and how that relates to slope. Number one, if two non-vertical lines are perpendicular, then the product of their slopes is -1. Oh boy, oh, we're starting to get into some fancy math speak there. Um, I, okay, it is true. The product of their slopes is -1. In a minute, I'm going to clean that up a little bit in a way that I think makes it a little easier to understand. Number two, if the product of the slopes of the two lines is -1, then the lines are perpendicular. So you'll notice this is a very logic-oriented thing. It's saying that this is definitional. Basically, if the lines are perpendicular, the slopes multiply out to -1. And if the slopes multiply out to -1, then they're perpendicular. In other words, it cuts both ways. It's a lot like saying, for instance, that a fork is a piece of silverware that has three or four or five different points at the end of it that you can stab into meat, or saying if you have a piece of silverware that can stab into meat with four or five different points on the end of it, then it's a fork. So it goes in both directions. Now, as far as maybe a little more practical, easy way to understand about if two lines are perpendicular, you could just say if the slopes of perpendicular lines are negative reciprocals of each other. What do I mean by that? If the first line of the first slope, m sub 1, slope first slope, is 3/5, then the second slope, m sub 2, is going to be -5/3. Negative reciprocal. Reciprocal means to flip the fraction, so 3/5 and 5/3 are reciprocals. And negative means you have to negate. If the first one's positive, the second one is negative. Of course, if it was the other way around, then you would, if it starts off as a positive, you have to get a negative for the perpendicular slope. If it starts off as a negative, you have to get a positive. Okay, so let's talk about a couple of examples. Slopes of perpendicular lines. One line is perpendicular to another line if its slope is the negative reciprocal of the slope of the other line. The following lines are perpendicular. Take a look at this first one right here. What's the slope? Okay, slope's going to be 2. What's the slope of the second line? It's -1/2. Those are negative reciprocals of each other. Remember, 2 is really 2 over 1. So the 2 over 1 gets flipped to 1 over 2, and the sign gets negated. Take a look at the next one. Y equals -4x plus 5, and y equals 1/4 x plus 3. What is the slope of the first one? It's -4. What's the slope of the second line? It's 1/4. Again, negative reciprocals of each other. Now, it's worth noting here, and I think this is very important, that I don't even look at the y-intercepts. I couldn't care less. They make no difference to me. The only thing that matters is the slope, and are they negative reciprocals of each other? So, next up, first question. Show that the line passing through the points -1, 4 and 3, 2 is perpendicular to the line passing through the points -2, -1, and 2, 7. Well, all you have to do in this particular problem is show that the slope of the first 2 points is the negative reciprocal of the slope of the second 2 points. Go ahead. Do both sets of points. All right, so the slope of the first set of points, I get 2 minus 4 over 3 minus -1. That works out to be -2 over 4, which is -1/2. Now, before I even find the slope of the second set of points, I know that answer has to be 2, because that's the only way to get it to be a negative reciprocal. And the problem says to show that they are perpendicular, so they better be perpendicular if that's what the question's telling you to do. Or I should say, if the problem's telling you to do. Now, if it doesn't work out to be that, either the question's wrong or there's something grossly wrong across the way. So I'm going to get 7 minus -1 over 2 minus -2. 7 minus -1 is 8. 2 minus -2 is 4. That's 2 over 1, which is 2. So yes, these are perpendicular lines because the slopes are negative reciprocals. Likewise, find the equation of a line that's perpendicular to the line passing through the points 1, 4, and 5, 2. So you find the slope of that first line that passes through 1, 4, and 5, 2, and then you create the equation of a line using y equals mx plus b that's going to be perpendicular to it. As far as graph the lines go, we'll do that on the next page. Okay? Go ahead. Okay, I think you've had time with stop and start to get this done. The slope of the line connecting those 2 points, I'll do 4 minus 2 over 5 minus 1, and I get negative 2 over 4, which is negative 1/2, which means the perpendicular line needs to have a slope of 2. So you can write any line you want here. I just wrote y equals 2x minus 5. I did that because it's going to fit nicely on the graph. Speaking of the graph, let's graph both and show that they are perpendicular. So go ahead, graph them and let's show it. Okay, I assume you did stop and start again. Here's 1, 4, and here's 5, 2, and there's the line connecting them. Now let's graph y equals 2x minus 5. Remember, this is in y equals mx plus b form. B for begin. So I begin at negative 5, up 2 over 1, up 2 over 1, up 2, well, I was going to do a couple more, but okay. There's my blue line representing that equation, and you can tell, you can tell that this is a 90-degree angle right here. Okay, see it in green? That's a 90-degree angle. It's perpendicular. Okay, so that summarizes our work on perpendicular lines and so on. The next lesson, we're going to begin to apply slope, looking at it as a rate of change and doing a lot of real-life applications with it. But for now, we have the basic fundamentals of slopes and parallel lines, perpendicular lines, graphing lines, different ways to find slope, etc., all in our bag of tricks. Have a great day.